In this last and optional part, I want to give you an example of a so-called spurious correlation. So spurious correlation means that there's an association between two variables x and y, but it is not a physical association. But not physical or not meaningful. And we will see that this association, if it's not meaningful, you can ask where does it come from? It stems from the fact that we look at only a subset of the data. So it's because of some bias in how we look at the data. And I include it here because even though you're going to see it's a very silly example, so you would never fall for that. You would never give it the wrong interpretation. But it is very common for statistical studies to be picked up and then to be given some kind of interpretation that they actually don't have. So you can compute a correlation coefficient, as we will do, find that it is significantly different from 0, and then decide, oh, these things must be associated. There's a correlation, there's an association. And then typical reaction is for people to say, like, now let me try and find an explanation for this correlation. But with the spurious correlation, there is no explanation other than the fact that we prepared the data incorrectly. We didn't look at all the data. So let's have a look in detail. So it's a made-up example, but it will illustrate the point perfectly. What we're going to do is we're going to look at the research question stated at the top of the slide. Are attractive people mean? And we might ground this in maybe an experience that we've had or some general observation. And our observation is, well, we interact with many different people in the course of our day, and we found on average that attractive people are meaner. Conversely, less attractive people are nicer. And I will let you fantasize a bit about whether this is true or not. Or even you could try and come up with a mechanism that would explain this. Maybe you say, oh, attractive people don't have to work so hard. They can afford to be mean, whereas less attractive people have to be nice just to be in the good graces of their friends. But this is not what this lecture is about. This is statistics. Let's put this question to a test. And before we get started, I'm going to be very clear about this. Obviously, there is no biological basis for such a claim. This is a nonsense claim, but it's one that you often see propagated in one form or another. And this is going to be an example of a spurious negative correlation. So the more attractive you are, the meaner you are. The less attractive you are, the nicer you are. Negative correlation. However, it's a spurious correlation, and we're going to see it is generated completely by how the data is generated, or in the real world, by how we observe the data. So let's get started. And this is, again, purely simulated data, so nothing is based in reality. Let's make a population of 500 individuals. And let's make it so that these people, these 500, have two characteristics: attractiveness and niceness. Both are numbers between, let's say, -10 and +10. And let's generate some fake data for these 500 people in such a way that attractiveness and niceness are not associated to one another. So I asked our random number generator to give me 500 values for attractiveness and then 500 values for niceness, and I made a scatter plot. That's the scatter plot that you see. And you also see there's no pattern visible whatsoever in between attractiveness and niceness. Also, if you compute the correlation in this sample, then you find a very small value for the correlation, negative 0.05. No pattern distinguishable at all. Now, of those 500 people, let's have a look at who we would want to be friends with. Well, we only have two characteristics to judge the people on, niceness and attractiveness. And maybe we say we don't want to hang out with people that are mean and not attractive. So the people that have niceness less than 0 and attractiveness less than 0, we don't want to hang out with them because they have nothing to offer. Remember, they only have two attributes, so if they score negatively on only those two attributes, there's no reason for us to want to be friends with those. So we exclude those from the group of 500 because we don't want to be friends with them. That means that we are left with this subset of the data. In particular, you see, I've excluded everybody who has niceness and attractiveness negative. All of these have been excluded. Now, if I compute the correlation of the data that remains, now I have a rather strong negative correlation equal to minus 0.32. Remember, before it was negative 0.05. So what we see here is that we have an association appearing, given by the correlation, but it's not caused by something inherent in those people. It's not that the nice ones are mean, the mean ones are attractive and the non-attractive ones are nice. It's just because of how we look at the data. This is an example of what we call in statistics selection bias. Selection bias means you get some trend in your data purely because you excluded some of the data before making your analysis. And in some cases, that exclusion is something that you do on purpose, but some cases it can also be unconscious. Maybe you ran a survey and your survey just didn't reach the people that don't have a phone, or maybe you did something and you just don't see part of the data, but it can still introduce a bias. It can change your results, and that's what we call selection bias. So with that, we are at the end of the entire chapter of descriptive statistics. So with that, you have both a set of tools at your disposal to look at correlations and visualizations and summary measures. And as one of the first PC practicals, you will put all of this into practice and you will make your own visualizations and your own measures of association. We will continue in person from next week onwards, and then we'll do a little bit of probability theory. So thank you for paying attention, and I hope to see you again soon in class.